Welcome to part 1 of this inverter project. In this video, we will build the double-sided PCB from start to finish. A good PCB is the foundation of a reliable inverter. Clean routing, strong copper connections, and accurate drilling all play an important role in the final performance. Let's begin the manufacturing process step by step. First, I printed the PCB layout on glossy paper and carefully cut it to size. Next, I cut the copper-clad board to match the dimensions of the printed layout. Accurate cutting at this stage makes the following steps much easier and ensures better alignment for the double-sided PCB. In the second step, I sand both sides of the copper board using 800 grit sandpaper. This removes oxidation and creates a clean, smooth surface, allowing the printed pattern to stick much better to the copper. Do not skip this step. It is one of the most important parts of the process and has a direct impact on the final PCB quality. Now it's time to transfer the PCB pattern onto the copper board. Using a hot iron, I carefully press the first glossy paper onto one side of the board. Next, I align the second layer using the registration holes and transfer it to the other side. These alignment holes are essential for a double-sided PCB. They ensure that both layers match perfectly, preventing connection errors and making the final board accurate and professional. After transferring both layers, I place the PCB in a plastic container and pour hot water over it. Then I wait for about 5 minutes. The hot water softens the glossy paper, making it easy to remove without damaging the toner. Once the paper is gently peeled away, the PCB pattern remains cleanly transferred onto the copper surface, ready for the etching process. Now it's time for the etching process. I place the PCB in a plastic container and carefully pour the PCB etching solution over the board until it is completely covered. The etching gradually removes the unwanted copper, while the toner protects the circuit traces underneath. After a few minutes, the excess copper is completely dissolved, leaving only the PCB tracks. This is one of the most satisfying moments of the entire manufacturing process. After the etching process is complete, I use acetone and a soft cloth to remove the remaining toner from the copper surface. As the toner is cleaned away, the bright copper traces become clearly visible. At this point, the PCB is fully etched and ready for the next manufacturing steps. With the PCB now complete, it's time to drill the holes. Using a rotary tool and the correct drill bits, I carefully drill every hole according to the PCB layout. This step requires patience and precision. Even a small mistake can make component installation difficult and affect the final quality of the board. Congratulations, the PCB is finished. This is the PCB for our 500-watt Pure Sine Wave Inverter, and it's now ready for assembly. In the next video, I'll show you the complete assembly process, component soldering, and the final testing of the inverter. See you in the next video.